Hey there. Today I'm solving the lead code number 35, searching insert position. Search insert position. So we are given an sorted array, distinct integer, all target value. So we have to find the target if found, index, target of index if found, not, if not, then return the insertion order at which place it should be inserted. These all process come to a log n, which is optimal solution, but we start with the brute force. Before dive into the code, I briefly explain what does the question did, that this is an array, sorted array. We want to find is 5 exist. Yes, 5 exist. What is the index of 5? 2. Now second example, in this array target is 2. Is 2 exist? No, 2 doesn't exist. But if I want to insert 2, where should I insert? After 1 and before 3. At index 1, 0, 1 at the index of 3, and shift the entire array by 1. Now the last example is the nums asking for the target value 7. Is 7 exist? No, 7 doesn't exist here. So where should 7 should be placed? After 6, which is a fourth place, the last element of the array. It's also known as a base case. Now let's start with brute force code. Brute force. Now int n is equal to nums dot length for int I is equal to 0. I must be less than n and I plus plus if nums of I is equal to target or is greater than target, like this. Here 3 is greater than 2, that's why we put 2 at the position of 3. Similarly here, like nothing is greater than 7, so and that condition is simply return n. Hopefully it's work. Illegal error, which is targets return I. Okay, symbol is wrong. Like this. Bingo. All cases are running, but it gave us DLE because they asked for big O of n. Not it. Okay, fine. But for a loop, if this run for a big O of n, not big O of n, big O of log n, therefore we have to optimize it. For optimization, what does we do? Only put int I low is equal to 0, int high is equal to 0, n minus 1, and while low is less than or equal to high, only till we run the loop, else we stop. Now firstly, for this is the syntax of binary. Whenever you are doing binary search, these steps are mandatory. One more step is int mid is equal to low minus bracket high minus low divided by 2, prevention of overflow condition. Now what we search, instead of we search for nums I, we search for mid. If mid is greater than or equal to target, if mid is greater than or equal to target. Where is mid? If this is an array, then high is low is 0, high is 4, 4 plus 2, 4 plus 0 is 2, sorry, this is a 3 and this is a 0, 0 plus 3 is equal to 3, 3 by 2 is 1.5, which is 1, therefore there is a mid. Is mid is greater than or equal to 5? If mid is greater than or equal to 5, mid is not greater than or equal to 5, not greater than and equal to 5, then what should we do? There is not equal to 5. If mid is greater than our target value, firstly we take a small. Is mid is greater lesser than our target value? Yes. Then low, new low is equal to mid plus 1. Similarly, else if mid is less greater than target, then high is mid minus 1. Last, else mid is equal to this, then simply return I. If none of the condition fulfill and this criteria is overflow, then the answer is low or high. It's high. Let's see. Not there is no ellipsis, therefore taken error. Out of bound. Why out of bound? Limit nums mid is less than target. Then less than target. Then we have to low is equal to mid plus 1.